Good afternoon, everyone, and welcome. I'm Alex, VP Marketing and People at Spread. Thank you for being with us today. A few housekeeping notes before we begin. Your microphones and cameras are turned off, so you can sit back and follow along without worry or interruption. We're recording this session, and the replay will be shared with you after the event. If you have any questions at any point in time, please use the dedicated form to submit it. We'll take time at the end to answer a few of selected questions, and we will send the full Q&A by email after the session. That's it for housekeeping. Let's jump right into the content. So what can you expect in the next 50 minutes? The main theme we want to cover with you today is from AI reality check to real use cases and how you can get started. Before we dive deeper into that, what this means and what this looks like, let's have a quick look who's with me today from my colleagues. We have with me Shane Connelly, our Chief Product Officer. Thank you, Shane, who will break down some hard lessons learned and where LLMs work and where they don't. And then I'm also very excited to have with me Oliver Blauth, who leads our solution consulting team and who will walk you through how this works in real engineering environments and how we bring this technology to our clients. So how exactly will we spend the next 40 minutes together? We'll start with a clear-eyed look why so many AI efforts in engineering stall, and then we'll show you two live use cases where we actually jointly with customers have delivered significant value. And finally, of course, we also leave you with how your teams and yourselves can get started in a fast and focused manner without major risks. Let's now ground this in the understanding of the real pain and the reality on the ground that engineers deal with in the day-to-day, especially now in the context of software-defined vehicles. What's the situation? With software-defined vehicles, complexity was meant to get decreased, but now that we have more centralized architectures, we have a much higher degree of interdependencies in functions and in the architecture as itself. So a lot more interactions that are happening, and the collaboration technology has not caught up with this. And human collaboration alone can hardly handle it. What do we mean by this? If you see here at the slide in the middle, a typical function before the SDV era used to be 3 people involved. So let's say 4 communication paths. Now with SDVs and a higher interdependency, we're talking 13 people and of course more than 8,000 communication paths. So that already shows what's the complexity and the degree of synchronization, communication, coordination, and alignment needed extensively. And of course, if you then take that into the typical org setups you see in manufacturing organizations in a matrix with vehicle line or product line, as well as domain responsibilities, this becomes a very complex undertaking that is slow, costly, and error-prone. So of course, AI could come to the rescue. I think this is what many are hoping for and what many expect, that AI will fix anything and everything, any minute now. And of course, there's a lot at stake. Research of consultants and industry analysts shows there's significant potential. And we also often see this from initial deployments with our customers. The upside is real. Over 15% operating margin potential, over 25% COGS reduction potential, over 50% R&D or SG&A cost down potential. Of course, also in terms of speed, 5 to 10 times faster time to market. From a production standpoint, 99% first pass yield. From a quality standpoint, significantly less warranty claims and warranty claims related cost. But all of these, of course, highly dependent on the context and are not easy to achieve. So why have we not all captured these wins already and see numbers like this and impact like this showing up in reality? Our perspective, while AI is advancing fast, the productivity has not caught up. and you see it a little bit shown here in the chart here over the period from 2021 to 2027, while engineering productivity has only improved by 6% a year, complexity has grown by 42% in the same time. And that gap of complexity and speed of complexity rising, outpacing productivity, that drives the workload and the effort. And AI alone, without being applied in the right way and being integrated in workflows, can hardly come to the rescue. Yeah? Many teams answer trying out POCs and pilots, and these end up in pilot purgatory, as we like to call it. There are many reasons, but now I pass it on to Shane, who will unpack for you a little bit our perspective on why we think that is, and we see a lot of AI initiatives ending up in pilot purgatory. So Shane, I hand it over to you.
Yeah, if you'll go ahead and advance the slide. Thank you. So in the age of AI and all of us seeing the impact that ChatGPT can make on our daily lives and seeing the explosion of large language models and the potential applications of them, I want to talk a little bit about the good, bad, and the ugly, but we'll go in the opposite direction. We're going to start with the ugly and continue to the bad and then go to the good. So one of the top mistakes that I see many companies that are starting to engage in AI-based applications make is trying to use generative LLMs for everything. There's many different types of AI type of workloads, and we're all very common at this point, or very knowledgeable about things like ChatGPT being a generative LLM, right? These are the LLMs that are creating new content for you. And so I've put up this documentation from the OpenAI documentation to show that this is not just my opinion, that people are overemphasizing generative LLMs. And there's several reasons for this. When you look at this, that OpenAI and myself as well recommend using the right tool for the job, right? So LLMs can be slow and expensive. I'll show a couple examples of this. There are often much better approaches for parts of the data or the data process than using a generative LLM for it. There's hallucinations, or what's actually more commonly referred to in the research organization as confabulations, because it doesn't know that it's making something up, and it doesn't know exactly what's being made up. And there's many, many more reasons to potentially avoid using generative LLMs for some workloads. Now, that's not to say generative LLMs are very powerful, right? We've seen how they're able to do really incredible things. We do use them at points within both spread the organization as well as spread the product. But sometimes it's sort of like using a sledgehammer to drive a nail. And sometimes it's like using a sledgehammer when you need an angle grinder, right? So you're supposed to use the right tool for the job, and that really does depend on the type of data that you're trying to deal with, as well as where that data stands and the relationship between that data and other types of data. And so next, I'm going to steal your screen share here for a second, Alex, and we'll talk a little bit about let's look at sort of what goes right and wrong in real world use cases when you have an over reliance on LLMs, generative LLMs. So switching to my screen share. And window here. All right, great. So first example that I'll show is something that will look very simple, but is hiding something underneath. And this is an example that I've crafted. Both these are examples that I've crafted that come from real use cases. So we've just opened this hello.pdf file. It shows hello on it. And I'm going to drag and drop this into ChatGPT, our favorite large language model, generative LLM that we all know about. And I'm now going to ask the LLM to translate the text of the attached PDF to German. And perhaps surprisingly to pretty much anyone is that the text here in the PDF reads goodbye, even though we all just looked at this and saw that it said hello, right? And it's not just PDFs, right? LLMs are still trying to learn how to read some of these file types in the ways that humans do, which is ultimately the problem that we're seeing here. And it's not just PDFs. Automotive obviously has a number of specialized file formats that LLMs have not learned or have not mastered yet as well. And so this is sort of a data cleaning exercise or data understanding exercise that really needs to be handled. And even if we just go with strict text and we ask, Google Translate, which is sort of operating a large language model under the scenes to translate "Hello Oliver," my esteemed colleague here that's on as well, to translate "Hello Oliver" into German, we get "Er ist über," right? And this is clearly incorrect. And these are a couple examples that I've crafted that are hiding some sort of data quality issues underneath. And really, it sort of points to the fact that when you're dealing with these LLMs, what you really need when you're engaging as a user of them is you really need a partner that understands how to build with LLMs as well as other ML models to get the most out of them. Now, these examples that I've just shown can be controlled for with the right ML and the right LLM combinations, with the right prompting mechanisms. And there are some other things that the LLMs can't do right now. But I thought I'd just show these as a couple examples that if you're not doing this, and you can imagine, the types of files and really ultimately the data that many of you are dealing with that is effectively between life or death of the end user, right, of your customers. Getting this sort of mistake wrong can truly have catastrophic implications. So that's where we focus on things like how do we clean up data, how do we make sure that data matches together with other bits of data that you might have, and focus on how those things can be appropriately used with the right tools for the job. The other example that I'll give here is just that LLMs are really bad at math. So I've seen a lot of users just pump any arbitrary data into an LLM. I've asked, for example, ChatGPT, let's suppose I have a right angle triangle, one leg's this long, one second is this long, how long is the hypotenuse? Now it gets the fundamental structure right. So it understands how to calculate a hypotenuse. But if you do any of these individual calculations where you ask for what this number squared is, it is not this number. If you ask for this number squared, it's absolutely not this number. The sum of these two numbers is not correct, and the square root of this number is also not correct. So in all of these cases, you sort of see LLMs are just bad at math, right? So people over-relying on them for that type of thing, there's much better solutions for numeric data basically. Now, that is to say, LLMs are starting to understand that they're bad at math and starting to, we and others are starting to employ what's called tool use to understand how to basically use a calculator when a calculator is appropriate. So starting to get a little bit better, but it's really important to understand what these limitations are, even in the context of tool use and calculators, so that you don't have, again, catastrophically bad things happen when you're trying to, I don't know, calculate the load of something or what the electrical impedance of something that you need in terms of a wire is inside of the automotive OEMs. So with that, maybe we'll talk a little bit about what good AI products do and don't do in the age of generative AI, and I'll let Alex start sharing as well, and we'll continue there. Great. So here's some of the things when I've seen application builders build with LLMs, what are some of the really good things to do and some of the really bad things to do. So spending as much time on the prompts as picking models. So a lot of times people are focusing on what's the largest large language model that's out there, and certainly much larger models can help to cover up some of the prompts that might be not as good, or maybe some of the data quality issues, but they're really expensive to operate. And there's often much better approaches to picking smaller models, but actually having significantly better prompts and feeding significantly better data into it that will both lower the cost of operations as well as actually increase the quality of the output. The second is, using clear roles and structured instructions in the prompt. So you say, I am, or you are a blank, Here's the very structured instructions, what you're supposed to do. Many people are often surprised when they first start building applications using LLMs to know that the best applications that are using LLMs in the world often have multiple paragraphs of prompts with multiple, maybe 10, 15, 20 instructions that are buried inside of them. If you're not thinking about that in terms of the prompt design, then there's a good chance you'll hit weird corner cases that you might not understand until way too late. Again, limiting the input size, there's sort of what's called the needle in the haystack problem inside of LLMs, trying to find really unusual data or something that might sit in the middle of a very long context window. So trying to feed enormous amounts of data into an LLM often, again, will both increase the cost, make it less accurate, and also significantly slow down the results as well. You should use them for tasks like summarization and classification. These are great tasks for LLMs. And there are now approaches to validating or attempting to validate the output of LLMs, the generative LLMs, using second adversarial models, which is quite good, where you basically try to use a second model to say, was the output accurate based on the following inputs? The second sort of on the list of don'ts, I've seen a lot of companies talk about fine-tuning models to add knowledge or terminology because they believe that it's required to handle the specifics of their industry or their business. Generally not a good idea. It's nearly impossible to remove that data if it ever changes or update it. And we use mechanisms, or largely the best mechanisms are for something called RAG, or retrieval augmented generation, to handle this type of data. Yeah, don't expect them to handle complex unstructured PDFs like I've just shown, sort of how they can mishandle PDFs. There's many other ways that the LLMs can mishandle PDFs if not taught correctly what the PDF structure is. And yeah, don't treat them like search engines, basically. I've seen a lot of people feed enormous thousands of documents into an LLM at the same time and then ask it to do something intelligent with it. It just often does not work, even the best models today. And when it does, it's extraordinarily slow and costly. So I've already shown the math bit, but as a group together, we need to avoid these AI traps and problems by having the toolbox again instead of this sledgehammer. We need to pick the right tool for the job. We need to understand where Gen AI works and where it fails, especially with this sort of industry-specific data types, the systems and processes that are unique to the automotive OEMs. That's really the value that Spread can provide. We do have the experts in-house that can understand the intersection between the space, the industry, and the latest AI. And with that, let's go ahead and progress to the next slide where we'll wrap up with the state of where AI is right now. So obviously what is advancing, I think a lot of people know that models are getting bigger every year. They're getting faster. They're starting to understand multimodal, which is, text, images, audio, video sort of stuff. They're still very early at the last three of those. You're starting to see more open source agents and orchestration tools, although frankly, everybody that I know that has started to go down the path of using those orchestration tools has really not enjoyed trying to maintain the updates and so on that those tools are doing. We've talked a little bit about how tool use can improve the LLMs. I'll show you in a minute how LLMs can start now generating some engineering files. I'll talk a little bit about some of the limitations to that. But engineering, no matter what, where AI is today, really with the hardest problems that we see and the most significant gains that we see from customers is starting to unify these different types of data, right? The bill of materials, your CAD data, your test data, your electrical systems, and so on, and bringing those all together. Because without that, you basically lose all of the context for the overall project and understanding, as we all understand, garbage in, garbage out. So with that, Alex, I'll turn it over to you, and maybe you can start talking about how, even though engineering stays hard, how Spread is starting to help make it less hard.
Thank you, Shane. So yeah, let me share a little bit more what Shane was already alluding to, what we do at Spread. At Spread, as you can see here on the slide, we spread product knowledge with functional virtual twins of all your product data to drive AI-powered decisions and actions. What does that mean? If you look here at the bottom of the chart, that means that our platform can ingest various types of data and acts like an intelligent orchestration layer. Type of data means anything from structured data, such as coming out of a product lifecycle management system, an application lifecycle management system, or an ERP, all the way, as Shane was sharing earlier, even unstructured data, such as PDFs, PowerPoint presentations, Excel spreadsheets, which is the reality today that around structured data and systems, there are lots of unstructured product data being used in collaborations. And we have the fundamental belief that the only way to overcome the complexity in the age of SDVs is by really unifying and integrating all of this dispersed product information and knowledge into one intelligent place. And this place, powered by an enterprise knowledge graph, we call product twins. So really, from the inside out, virtualizations of various products your companies are developing, building, and maintaining. What we do with this information? You see on the left side, we have an environment called flows, where you're then able to custom design the workflows you need for your analysis and data transformation to power your business. As well as on the right side, we have a low-code environment called Studio, where you're able, in a few clicks in a low-code environment, to configure your own applications to analyze and transform this data the way you need. And then on the very top, we call this our Action Cloud. We have our solutions. Here are 3 examples of solutions, such as Product Explorer, Inspector, or Action Tower. And these are sometimes, if helpful to you and in the particular use case, and as Shane said, when it makes sense based on the use case, further enabled by systems of AI agents, or these are purely human-powered applications used in your flow of engineering work. So that's a conceptual overview, what our platform does and the element it contains, and some of the organizations at the very top that use it. But now, Shane, can you show us a little bit what's under the hood?
Yeah, let's go to the next slide. And we just have a little video here to walk through. So Spread has really thought a lot about how to structure this sort of engineering intelligence graph around mechatronic systems. This is a visualization of our graph. You can see it's quite comprehensive. We have entities and relationships going all the way up and down, from requirements to functions to components, wiring harnesses, wires, CAD data, hydraulics. We have this sort of system to handle variance and how these entities change over time. It is really exhaustive, but because it's so exhaustive, and because our customer data tends to be both very sensitive and many people want to get as much value as they can as quickly as possible, we want to expedite how we can get that data into this schema as quickly as possible to show value for you. So with that, I'll show you, I've talked a little bit about some of the ugly and a little bit of the bad. Let's start hopping over into some of the good things about LLMs and some of the things that they're now capable to do using Spread. So I'm going to take your screen share here again, Alex. Mm-hmm. So here is an example where I have asked ChatGPT to create a KBL file that represents electrical parts definition. And you can see actually one of the things that ChatGPT is quite good at is creation of things. Now, I have no idea how many hallucinations or confabulations are inside of this XML file, but that's sort of not terribly important. You can see that with O3 Pro that it thought for 18 minutes before being able to craft one of these KBL files. But we'll just take it as something that might have come from a customer and start to show some of the power of Spread. So we've pasted this in as an example, right? We've got wires, we've got cross sections, we've got the wiring harnesses, some specific components, connectors, and so on, right? And so what we're trying to do here is basically take that graph that was on Alex's screen and start to map over customer data into the schema that Spread knows about. So it's our schema, but it's your data, right? And so we'll ask something like, let's get started. Right, so this is one of the AI agents that we have inside of Spread to help basically expedite that data jump, if you will, from again, your data over into our schema. So from here on, I can just sort of say, okay, it says I see general wire that's here. And based on this, I think I should map this over into the wire entity inside of spread. Sounds good to me. And then our AI assistant's going to start looking at some other things like, okay, this ID looks like a unique identifier. Let's go ahead and apply that. Part number looks like a part number ID. Good. And so you could imagine that I'm not going to go through the full file. It's rather lengthy and rather complex, but you can go through and basically start mapping out your colors, your cross-sectional area, metadata that might associate with this, terminals, and so on, right? So that's how part of the ways that we're helping customers start to really understand how to map their data over, or us helping them map the data over. Our data mapper can handle many different file types. As Alex sort of mentioned, we handle XML files, arbitrary KBL files, requirements files, REQIF, spreadsheets, PDF, and many other file types that can be mapped over into our graph. And since I've sort of shown how to map the data quickly, maybe I'll move over to Oliver, who can sort of walk through the rest of the way on how we onboard customers quickly.
Sure. Thank you, Shane. So, hey, let's zoom out and let's double check how does this really affect our full solution suite here. In the past, this took you up to 6 weeks of connecting an app or even doing prep the connectors. Now, it just takes you a couple of days, a couple of hours, as you have seen. So it's not just faster, it's even better now. So let's take a look at the e-inspector, a solution of troubleshooting using KBL files as a data input. We start on the main page where you can search test reports, either by VIN, production number, or filter by plant, building, or test station. You can also just pull up all available reports like we're doing here. These reports come from production and are used during inline or end-of-line testing. When a vehicle is connected to a diagnostic tester, faults will show up. The tool helps identify the root causes fast so the vehicle can leave production without any delay. So let's open one of the reports. You will see a 3D shell of the vehicle loaded with wiring harness and components specific to this VIN. You can also switch to a 2D model, a view, and many rework teams prefer that, but it depends really on the use case. Now, here's a key feature. We don't just show the full 150% BOM, bill of material, or wiring harness. We reduce it to the exact configuration of the vehicle you're working on. That means you only see what's physically installed in this specific car, no optional variants, no clutter. This filtering is based on the KBF, the wiring harness list, and cuts out all noise. On the top right, you already get automated root cause suggestions using what we call focus analysis. On the bottom right, you see the actual reported errors decoded with full technical context. Clicking on an error loads its details, connectors, wire colors, pin info, even photos of the connector faces. All of this helps the rework team quickly track down the issue in the wiring system. Now, let's look at the focus analysis. If the tool sees the 2 faults run through the same connector and others don't, it highlights that component as likely fault source. So instead of guessing, you go straight to a high probability fix. Maybe a loose connector, bent pin, or even a damaged wire. So you can even locate that part in the 3D model to see where it sits physically in the car. So to sum it up, the e-inspector speeds up rework by pulling in all relevant data, filtering it down to the exact configuration and suggesting likely fault causes. That means faster fixes, fewer detours, more issues resolved inline, and a higher direct pass rate, which is exactly what production KPIs aim for. All right, let's go to the next slide. So as we have seen, the AI mapper accelerates every spread solution from Explorer to upscaling coach. It's not a one-off. It lifts Explorer, Architect, Action Tower, the Inspector, and the coach. The time to value drops 5 to 10 times across the board, and that's how we scale. So Shane, let's talk about the next frontier of AI agents. How engineers can interact with AI actually. Do we have a demo to screen share?
Of course, I would be happy to. Let's hop into a demo here. So this is one of our demos. We call it Issue Assist. This is part of a more broad aftermarket, especially set of solutions that we have inside of Spread. And you can imagine, or what we have many conversations with customers and prospects about is that they have many different workshops that might be around the world that speak different languages. And when those workshops have some sort of issue with a vehicle, they many times can solve it themselves using existing diagnostics and so on at the workshop, but sometimes they need help from the manufacturer as well. And in those cases, there's a ticketing system typically that goes back into a team that needs to look into potential problems, right? So here's a sort of simulation of a number of different tickets that might have come through from different places. Now, you can see here the icon representing the different language that these were coming through. In this case, it might have been English, but we can also navigate into, say, Spanish and so on. I'll walk through a live demo of this as well. So let's just go ahead and suppose we are a new ticket comes through from a workshop. I've already got a sample here, but it's a vehicle that has a problem with keeping lane assist on the highway when it's hot outside. But it's coming in from our Spanish-speaking colleagues that are in a workshop, and they're going to go ahead and submit this issue. And what happens behind the scenes is that Spread is going to automatically translate and summarize the thread for the end user as well as for the headquarters. So let's just see if we can find, there we go, that ticket. And we can see that our Spread AI has generated a summary of this, right, which is not currently anything or much more than what the ticket already has. But we could imagine that maybe the German colleague responds, and maybe they're not being a Spanish speaker and they didn't even type in English, right? And we're going to go to German. My German's improving, but not quite there. You can tell me if this is totally off. But let's suppose that the comment comes back through and says, we're looking for, have you looked at ECU 375R, for example? And again, what will happen is Spread's AI will go through and translate and summarize, right? So we've got the updated summary and now a new comments summary as well. And again, we can imagine our Spanish workshop says, yeah, we already tried that. We also checked the temperature sensor and we haven't found anything. Right, and again, Spread's going to go through and translate and update this. We see the comment summary has basically been updated, that they were investigating ECU 375R. We've replaced it, so still unable to diagnose the issue. Now, at this point, maybe at headquarters, I need to start investigating similar issues. So from there, this is one of those occasions actually that using a generative LLM for finding similar issues is not a good use case for it. There's much more efficient mechanisms, and still using a textual similarity or semantic similarity, which is what we do. So maybe I want to go off and investigate some of these other tickets. This one looks like a high probability or high interest, right? So, oh yeah, this looks really similar, right? And maybe at this point, though, I still haven't found a solution. So I might want to go check out some of the related requirements. So at this point, we're able to navigate basically into the graph structure of spread to understand the other related components, whether they be a component or requirement or otherwise, that might have affected the ticket, right? So we're going to dive in here. We can see what the specific requirement is. Okay, if this is true, then set this to inactive. I can start, again, looking into similar requirements from here. I can start looking into actually the graph of how the requirements relates to the various ECUs. We can use an AI agent actually to extract the signals out of this this condition here. So, we see that if the following conditions are met, now we get basically a graphical representation. We can store this back into spreads graph as well, right? So we're able to understand basically this full text requirement and pull it back in. And at this point, maybe I still haven't found anything, so I can start diving into the overlay of the CAD information alongside where maybe the individual ECUs lie and start diving into the specific electrical wiring diagrams as well, which again, as Oliver mentioned a little bit earlier, what we're basically doing is condensing the vehicle information that we know potentially from a VIN all the way down from the 150% or 200% down into the 100% that's a very specific vehicle to understand exactly how the electrical system might have been laid out for this to really help both the engineer that might be working on this at the headquarters as well as the workshop person to really understand what they're looking at and help to diagnose that problem earlier. They might be able to, or they might dive into the various files, like all the requirements documents and so on. But from there, basically, we can hop off into a bunch of different places inside of this graph and build these applications up. So that is the demo. Hopefully that helps to understand some of the places that we're using both AI agents as well as other AI capabilities. And with that, I will kick it back to Oliver to talk a little bit about maybe how to get started with Spread.
Thank you, Shane. Hopefully you're all wondering now what the first step look like for you. So what we see at our customers is that they really started with one fast win solution and scaled from there. So literally no one bought everything at once. Everyone basically picked up one case, and that first win came in weeks and not in years. And from there, they scaled really what worked out. So in summary, we first of all run a discovery, scope a few use cases, and then really ramp up the value and usage and scale to the next cases. Next slide, please. Awesome. So if we connect the dots here and what's the overall difference Spread makes. So Spread is built basically for fast onboarding, low IT involvement, and the rapid deployment. And most CIOs ask us, is this a big integration project? And the answer is no. We plug into your data, not into your infrastructure. And that basically fuels fast outcomes in a software as a service model. And we have a proven path how to do it. And with that, we will just have a look on our roadmap and how we deployed our customers. Next slide, please. Perfect. So coming back to Shane and his great demo about the AI mapper. So Spread is using the AI mapper and the product twins and slash deployment time and unlock compounding return on invest. Because most of the time goes into structuring data typically, and we partially automate that step. So one ingestion fuels multiple solutions fast, and you move from weeks of prep to days or even less. So we can really capture the first value with, for example, the Product Explorer, and then evolve over time and plug in different solutions from our platform, like the Inspector, the Action Tower, and the Product Architect. And so before we wrap up, let's recap what some key takeaways for your team are. And with that, back to you, Alex.
Thank you, Oliver. So a bit of text on this slide. So let me highlight some of the key points why, as Shane alluded to earlier, we at Spread are a great partner for AI-related engineering challenges and how to overcome them. Yeah? Really using data and the right solutions and not defaulting to LLMs and ending up in pilot purgatory. Why us? Why Spread? We are a vendor that provides the fastest time to value, synergies, and agility, as Oliver just shared. And what makes us stand out? Number one, in our team and from our founders, we have a deep engineering DNA. Spread has already supported leading OEMs in multiple domains and in multiple industries, managing complex systems such as vehicles, trucks, planes, drones in millions variations and many different platforms. So when we talk engineering, we really understand the data and the products you are developing. Number two, this is not theory, this is proven enterprise success. Spread creates measurable value from early deployments all the way to service and across functions, software, electronics, communications, diagnostics, and configuration. Number three, we use really use case speed and we get it done fast by really integrating and ensuring system integrity. What does that mean? We connect engineering, product, and service data all in our scalable platform that is made up of the components I shared in a little bit of detail, and we make it easily accessible with low-code solutions and assistant tools. And that allows you to enable and realize use cases in days, not in months or years. Number four, at the very starting point, how do we get your data ingested into our platform so that it can be used? It starts with ready-to-use data connectors. These are built-in integrations for engineering, production, and service systems, and they accelerate the ability to deploy and reuse existing infrastructures. And last but not least, we always like to highlight we're building from engineers for engineers. So these are not tools that are theoretical or methodological, but they're really proven in the field, in the trenches with users, and they have delivered real value. And so how they are built, both in the front end, middleware, and the back end, they really reflect and understand how engineers and users operate in the field and hence enable the right focus and don't require massive customization. And of course, this also makes it easier to realize value fast, have high user acceptance, and implement fast. So that is, if you will, the secret recipe, how we ensure a fast time to value and bring the power of AI to the engineering domain. So what are some of the key lessons that we would like you to take away? And that's why we named the session from an AI reality check and some of the challenges we hear about and we see quite a lot, to real use cases and how to get started. And so, Shane, I turn it over to you.
Yeah, so I'll cover the first one at least. One of the things that, again, hopefully you've seen here is that an over-reliance on LLMs to produce truthful, accurate content on the output, especially generative LLMs, can really cause catastrophic outputs for, well, especially when the data that we're looking at is so critical and human lives, again, are at risk. So LLMs, generative LLMs, they're not magic. They're statistical. And at the end of the day, having really well-structured data is what matters the most to get the 10x out of the models, right? So even if the model is 10x tomorrow in terms of size, I would not expect that we end up with nearly as much gain for customers as simply making sure that the data ends up in the right place inside of an intelligent network like Spreads. And so that's really where I encourage folks to encourage to structure the data in a way that makes sense, especially across different systems.
Yeah, and to add on, so thank you, Shane, we've productized that structure, and mappers and twins mean speed and ROI. Yeah, we've used various types of technologies such as graph technology, SaaS solutions, and agents for impact. And impact means really going from pilots to a pre-built platform and turning engineering structure into real ROI in terms of speed, cost, and quality. Ollie, I think you have also something to add.
Yeah, to basically finalize that is basically what we really recommend is that you land with one solution very fast and then scale up from there effortlessly on the Spread's shared context foundation. So what we really mean with that is that we roll new use cases without replumbing data or teams so that we really can make the most out of your data and spread all the information within your enterprise. Back to you, Alex.
Thank you. Yeah, and as you see here on the right side, yeah, of course, we also do want to answer your questions, but when you're ready to join us on this journey and you want to learn more, of course, even outside of the Q&A, please feel free to reach out to us and ask us anytime, sharing your specific contacts and needs, and we're more than happy to pick it up. But now let's jump into the Q&A. So maybe, Ollie, I turn it to you. I think we have a first question I see here in the chat.
Sure. Let me check. So what does it take to get started and what's the typical resource load? That's a great question. And as I showed already, or as we explained to you in the last kind of 50 minutes, is that what we do is we do a discovery with you, try to come up with the most beneficial use cases that really help your business and your organization, and then try to bring this together. And what we need from your side is someone basically who is guiding us from a business side, so really to find out where the business value lies for you. And on the other hand side, someone from the IT folks who really help us to connect to all the different data sources. And then we can plug in to our applications and we can take it from there. I hope that will answer your question, Alex.
Thank you, Ollie. And I think if I see the next one, Shane, that sounds like something for you. So I turn it over to you.
Sure. Yeah, so the next question looks like here is, how do you handle poor data quality across multiple files and databases? And honestly, the answer to that question is like many things, it depends. It depends a bit on what the poor data quality actually is. So we've seen our fair share of these different types of poor data quality, or what I would consider poor data quality. One is, for example, bad field names or bad spreadsheet column header titles and so on. That can often mess up many other systems. But again, by using our AI Copilot mapper, that can help to sort of address some of those. Linking data together across multiple systems can help quite a bit as well. There can be low data quality. Somebody considers sometimes low data quality things like PDFs that need to be OCR'd and so on. And again, we've built sort of systems in-house to help do some of those types of things as well on our side. But it really is about making sure that you understand the data first and what the types of low data quality are before you jump to a conclusion of what the right solution is. Oliver, I don't know if there's anything else that you've seen that you want to add to that.
Oh, that's fine. Thanks, Shane. Great.
Cool. Then I think, Ollie, the next one is probably a mix for us between the customer and the solution consulting domain. So the question here is, how long until we see first measurable value? Maybe, Ollie, you want to get started, and then I'm happy to add on.
Sure. Thanks, Alex. So what we typically see, and this is not kind of, we don't want to overpromise something here, but I think after 3 months, or 12 weeks or whatsoever, we should be in a very good position to really make your data accessible and show them into our apps and applications. So that would mean after another, I would say 3 to 6 months, you should really see first measurable values and results. So I think within the first 6 months, you should really see the first indications for impact. Anything to add from your side, Alex?
Thank you. Thank you, Ollie. Yeah, I would just add, of course, as Shane also shared, right, we take also the complexity in this domain and picking the right approaches, understanding your context and doing things properly seriously. So that's why we give you such an estimate. Of course, there could be situations, as we say, it depends, where even something faster is possible, but that will be highly dependent on which solution are we talking about, how ready is the data, how easy is it to get access to that data, and that will largely drive the speed of which it's possible to realize value. It's less what you might expect anyhow related to the readiness of our solutions, as we largely rely on highly pre-configured out-of-the-box solutions. Maybe next question here, Shane, this sounds like a technology-related question that I'd happily turn over to you.
Thanks, Alex. Yeah, so the next question I see here is AI projects. What common mistakes should we avoid? I think I've covered a lot of the ugly stuff here already, and some of the bad stuff as well. I think some of the other things, just from an organizational perspective, that I'd suggest folks look at is one of the bigger mistakes that I saw was organizations trying to build something themselves. It was really catastrophic. So in past lives before I joined Spread, for example, the best customers that we had were the ones that tried to build something themselves, and then 1 year later had completely failed, and then were looking for a partner because they realized it was so difficult to wrangle these LLMs in a meaningful way to build actual value for the business, aside from just giving your employees access to ChatGPT or whatever else, right? So that's really one of the biggest organizational mistakes I've seen, is these systems are quite complex. Coming up with the right systems that can do the right prompting with picking the right tools for the job again, it really does require a deep level of expertise. And there's very few companies, even extraordinarily advanced, Silicon Valley companies that do software in and out, and even some AI stuff, consistently make mistakes with AI type of projects. So I really encourage folks to try and pick a trusted partner with any AI-based projects that they're trying to do. And it really can produce enormous value back to the organization, really accelerate your users if you're picking, again, the right partner and choosing the right solutions for it.
Thank you, Shane. And I think there's one more and one last, if I look at the time, technology-related questions. It's a bit like peeking into the kitchen of our Michelin star chef. So Shane, I'll pass this one over to you as the last question.
That's a good analogy. I like that. What are the large language models that Spread uses is the question. So we use a variety of large language models. Again, we don't even always choose a generative LLM for a variety of tasks. We have the ability to deploy. What we've seen is that there's some sensitivity to some customers using certain types of LLMs, whether it's for business reasons or some sort of geopolitical reasons, for example, potentially related to international problems and so on. So we actually provide a number of different options for our users. Of course, we provide ChatGPT, OpenAI's models in general for our users. Common misconception, I guess, there is the way that we use OpenAI does not let them train on data that's from our customers. But we also, for those that are much more privacy focused, we have offline models as well that we can use. And Mistral is currently one of our favorites for using, but we have several other models that we both deploy and are experimenting with for the highest quality output for the right trade-offs with different businesses.
Thank you, Shane. I see there's a few more questions that now we are not able to get to. So please bear with us. We'll try our best after this webinar to get back to you with dedicated answers. So that only leaves me to say thank you very much for giving us your valuable time, for joining in today and listening to Shane, Ollie, and I. We're very excited and happy to showcase here a little bit as an early sneak peek what Spread can do, what Spread can do for you, and what it can look like to bring the power of AI to engineering and really speed up development cycles and realize productivity gains side by side and beneficial for you. Thank you very much and see you soon.
Thank you.